Haven't you always wanted to build a chicken coop? So, the idea is you're building a fence to keep in your chickens. Okay? You've got 80 meters of fencing, and you have a barn, so you can use the barn as one side. So, here's my barn, here's a top view, there's my barn. I can build all sorts of different shapes off the sides. Okay, and what we're going to do right now is we're going to make, I don't know if I say it in here, we're going to make a rectangular, dimensions rectangular, you can add in here. Now, you could, not very practical, but you could decide to go 1 meter this way, 1 meter this way, and then you would have 78 meters left, and all your chickens could do is walk in a long straight line all day long. Okay? Can you see if you did this, I mean if this was a grassy area that they could eat something or sleep, that you would have 78 meters squared for those chickens. However, if you decided to be a little bit more reasonable, okay, and made this a little bit longer, throw out a number. 5. Okay, we'll go with 5. That would use up 10, and how much would be left here? 70. Right? And then you would get 350 meters squared, right? And if we draw pictures of chickens, ooh, this is dangerous. This is sad chicken.
Where did we get the 5 from?
Happy chicken has more space,
Where did we get the 5 from?
right? Yeah. We're just making something random right now, just to see different examples. Okay? Don't write it down yet. You can draw them. Right? You have to, yes, make sure you draw the chicken. That's important, right? Sad chickens make small eggs. Happy chickens make big eggs. And that's why the chicken is so happy. It's so good to get that thing out. I know. Oh well. Okay. Now, we want to find the maximum area. So area is what we'll set our equation up as. We want to find our maximum area, so it's going to be area equals. How do you find area? Let's just write it out. What's the formula for area? Length times width. And so we don't know what the length and width are. We've done some examples. We saw when it was 1 and 1 and 78. We saw when it was 5 and 5 and 70. So now we're going to erase these numbers and use the same concept that we did before with real numbers, but now we're going to use algebra because we don't know what the sides are going to be. So I'm going to say this side is x because that's what we started with last time. If I know that side is x, right across will be x as well. Now what's left on the bottom? Well, you could figure it out last time. 80 minus x plus x, or 80 minus 2 of those x's, right? Because if it was 5, we subtracted 10, because it was 2 5s were used up. Now we can go to our equation. The length was 80 minus 2x, and the width is x. Can you see that that makes a parabola? Because if I multiply it out, 80x minus 2x squared And I rearrange it so that the x squared is first. So the hard part in all of these is coming up with the equation. That's step one. Once you've got that equation, now we need to find the vertex. So how do we find the vertex? We do that by completing the square. Factor out the -2. Leave a space. Notice there was nothing there, so it'll just be a space on the other side of the brackets. What goes in the first blue space? Because I took the -2 out of the first two terms. 400. That's -40. -40x, now it'll be plus 400 because we take that -40, divide by 2, and then square. Now what have I actually done? What have I actually done? I've subtracted 800.
So now you gotta add 800.
You have to undo what you did. If you do it on the same side, if one is subtracting 800, then the other one would have to be adding 800. Right? In the other one, in the other square that we did earlier, we had the spaces on opposite sides of the equation. So what you do to one side of the equation, you have to do to the other. But now that they're on the same side, in order to cancel out, one will have to be the opposite of the other one. Because that -2, you see the black line, hits that 400. So we always have to, and if you look back at your notes, we had a special thing there, remember to multiply by that a value. And now we have -2 x minus 20 squared plus 800. So what's our vertex? $20 and 800. This was our y value, but we're not using y right now. What does that 800 stand for? That's area. And because it's our vertex, it's going to be our maximum area. And this is x. And what did x stand for in our question? The width. Okay? So let's put that as a note as well. If we draw a quick picture of this, somewhere here we have 20, 800. The parabola is going down because of the -2.
So would rewrite the 20, 800, can we draw that like anywhere on the graph? Or what?
I am, yeah, like, this is 400. I'm making my own scale.
Oh, okay.
And you can choose your own scale so that it fits. Now, if you wanted to show this on your graphing calculator, that's the kind of window you would need to look at in order to see it. Okay? What did the question ask us to find? What dimensions will yield the largest area? So we have to say the dimensions. (20 meters by how much would the other side be?
-0.
Let's look at it. If this is 20 and this is 20, how long is this? 40. These chickens are, you should see the egg these ones make.
That's where the extra large ones at the grocery store.
Would be, oh yeah, that's not a very good English there, eh? Would be 20 meters by 40 meters. So 800 meters squared. If you had 80 meters of fencing and you could do whatever you wanted, Building it 20 by 40 would give your chickens more space, but not cost you any more, as opposed to building it 1 meter by 78. Or you could build it 1 centimeter by 79.98 meters. And the chickens would just have to waddle like that all the way along. Well, then you would have to have new considerations, right? And we've only considered rectangular areas. What shape calculus would go into if you could build your fence in any shape possible? What shape should you build it? How should you make your shape into a parabola? Or should you make it into a circle? Or a triangle? So, to summarize what we did, we drew a picture. We assessed the information. Sometimes it's helpful to actually use numbers to see what happens. We used 1 and 1 and 78, then we used 5 and 5 and 70, and we could see through those examples how we got our numbers. Then you use a variable so that you can actually create an equation and complete the square.
So would a equals -2 bracket x minus 20 squared bracket plus 800, is that the equation?
That's the equation, and that's the equation in this form, right? And that form tells us everything about it.